Okay, so what if you have a system of equations where you have different coefficients? Like we have an a here, another a there, but the coefficients are different. You check the b's, the coefficients are equally different. What do you do in a case like this? So to solve a problem like this, you can just draw a line here, and then if you want to eliminate the x variables first, the a variables first, you can get the coefficients of a and then put them this side. If you want to eliminate the b's, you get the coefficients of b's and put them this side in this manner. So for me, I'll eliminate the b's because they are much easier to eliminate. I'll show you why. So I'll get the coefficient of b here, which is a 2. You write it here, and then the coefficient of b here, which is a 1, then I'll put it on top. So as you can see, the two coefficients have been swapped. So I'll multiply this number by each of these numbers in the first equation, and then I'll do the same thing here. So let's say 1 multiplied by 2a, this will be 2a. Then 1 multiplied by 2b, this will still be 2b. 1 multiplied by 10, this is 10. So that makes 1 an excellent choice. If I had picked 3 and 2, then this would be like 3 times this, 3 times this, 3 times that, which would have made the work even harder. So now you have 2 multiplied by 3a, which is 6a. Then 3 multiplied by b, this will be positive 2b. And then 2 multiplied by 3, this is a 6. So as you can see, the coefficients of b are now the same. We have a 2 here, and then we have the 2 here. So to eliminate the b, you can just use the method we looked at in assignment 2. So I'll multiply one of the two equations by a negative number so that we can add the two equations. So I'll multiply the first one. If you want, you can use the second one. So I'll multiply this by negative 1. So negative 1 times this would be this, negative 2a. Negative times this, we have negative 2b. Negative 1 times 10, we have negative 10. And then we write the other equation as it is. Then at this point, you can just add the two equations to eliminate the b. So negative 2a plus 6a, this is 4a. You can just do it like this if you are doubting. So when you have different signs, you subtract, and then you get the sign from the bigger number, so that you have 4a. And then when you add negative 2b to positive 2b, this will simply be a 0, as you may have seen from assignment 1 and 2. And then negative 10 plus 6, this is negative 4. Remember, you have negative 10 plus 4, you have different signs here, so you can subtract and get the sign from the bigger number, which is 10. So now you have 4a is the same as negative 4. To solve for a, you can simply divide both sides by 4, and then your a will therefore be negative 1. And you are done on the part of the a. And then to solve for b, you can pick one of the two equations. You can either pick the first one or the second one. For me, I think the second one is much easier because I have smaller numbers and then the b has no coefficient there. So I'll pick the second equation, which is 3a plus b is the same as 3. So now we know that a is -1, and then we know that the relationship between a and b is this. So to solve for b, you can just substitute your a there. Your a is -1, then plus b is unknown. Equate this to 3. Then 3 multiplied by -1, this is -3 plus b, which is the same as +3. And then to solve for b, you just collect the like terms. So you have a 3, you take the 3 to the other side, you have a +3. 3 plus 3 is 6, and you're done. So this is how you solve simultaneous equations when the coefficients are different. Let's look at another example. So we have another example here. So in this example, you are free to choose which one you want to eliminate first. If you want to eliminate x, you can just put this and then get the coefficient of x, you put it here, you get this coefficient of x, you put it there, and then you multiply like this. So for me, I'll eliminate the y first. It won't make any difference if you decide to eliminate the x variable first. So I'll get the coefficient of y like this. This is -3, and then I'll get the coefficient of y, and then I'll put it here. In fact, you can even ignore the negative sign unless you just want to keep it there. Either ways, you still get the same answer. So 1 multiplied by x, this is x. Then 1 multiplied by -3y, this is still -3y. Then 1 multiplied by 8, this is still an 8. Then you have 3 multiplied by 3x, this is 9x. And then 3 multiplied by y, this is +3y. Then 3 multiplied by 4, this is 12. And then to solve for x and y, as you can see, we have the same coefficients of y, and the signs are different. So we can simply add the two equations. So if you decided to keep this as a negative number, then all these would be negated. And then as a result, you may have to multiply one of the two equations by a negative to make the signs different. So we have another method to solve such problems, but for now, I want us to concentrate on this particular method. So now let's add the two equations. X plus 9x, remember this is just like 1x plus 9x, so this is a 10 with an x, and then -3y plus 3y, because the signs are different and the coefficients are the same, this is just a 0, so that means the y has been eliminated. And then we have 8 plus 12, this is 20, and then this is like 10, x is the same as 20. And then to solve for x, as you may have guessed, you can simply divide both sides by 10. And then you have x is the same as 10 into 20, this is 2. And then now you can pick one of these two equations to solve for y. Of course, you can even pick from here. It's actually better to pick from these two. So now I think the second equation is much easier for me. So if you think the first one is easier, then you can go for it. So I'll go with the second one because it has less negative numbers, and then the first one only has, the first one has negative numbers, and we have an 8 there, which is bigger than 4. Anyway, I'll use both for this particular example so that you can have both methods. So we have 3x plus y is the same as 4 as our second equation. And then to solve for y, you know that x is 2, so you can just substitute this in there so that you have 3. Where you have x, you put your 2, and then plus y is the same as 4. Then this multiplied by this is 6, plus y is the same as 4. Then when you take the 6 to the other side, it will be negated so that you have 4 minus negative 6. Then y will therefore be negative 2. And you're done. So now let's use the first equation instead and see if the answer will still be the same. Let me just write it down. This is x plus minus 3y is the same as 8. This one here. And then we know that x is 2. By the way, you don't have to use both methods. Just choose one. If you decide to use this, you don't have to use the second one, unless you just want to verify your answers. So x is x is 2. So where we have x, let's just put a 2, which is the value of x, and then minus 3y is the same as 8. Then you can collect the like terms. You have 3y here. I'll take the 2 to the other side. Now remember, this minus 3y has not been moved, so you leave it as it is with its negative sign. So this will be 8 minus 2. Then this will be negative. 3y is the same as 8 minus 2, which is 6. And then to solve for y, you can simply divide both sides by minus 3. So this will be minus 3 into 6 is minus 2. Same as before, so that means whichever equation you pick, you still get the same answer, except that you get to have some extra work when you pick one that is a bit more complicated than the other. So now let's look at the third example. So we have different coefficients of x, we have different coefficients of y. So now to solve for x and y, you have to eliminate one of the two variables. But to do that, you have to ensure that the coefficients are the same first. So let's say I didn't want to eliminate y first, as we did in the first two examples. Let's say I want to eliminate this one. So if I want to eliminate this, I'll get the coefficient of x and the coefficient of x and put them here in a reverse order. So I have a 1 here, can put it there. 1, which is the coefficient of x, and then we have a 2 here, which is the coefficient of x, can put it there, and then now we can multiply these two by each of these three terms. So you can say 2 times x, this is 2x, then 2 times negative y, this is negative 2y, then we have 2 multiplied by 1, this is 2. Then we have 1 multiplied by 2x, this is 2x. 1 multiplied by positive 5y, this will be positive 5y. Then this multiplied by this will be 16. So if you want, you can even negate one of these two variables so that you skip the part of multiplying one of the two equations by a negative number. Or you can just pick the coefficients of y variables. But for now, I just want us to go back to assignment 2, which requires you to multiply one of the two variables by a negative number. So you can pick one equation and multiply it by a negative number. And for me, I'll pick the first one because I know that once I multiply this by a negative number, I'll have at least one positive number here. So negative times positive, this would be negative. So we have negative 2x. Negative multiplied by negative, this will be positive 2y. Negative multiplied by 2, this will be negative 2. And then lastly, we have the second equation, 2x plus 5y is the same as 16. So now, since we have different signs, but the coefficients are the same, we can add the two equations so that the x is eliminated. So negative 2x plus positive 2x, this will give us a 0. So we have a 0, you don't have to write it unless you just want to. And then you have 2y plus 5y, this is 7y. And then negative 2 plus 16, this is like negative 2 plus 16, where you have different signs, you subtract and then you get the sign from the bigger number. So we have a 14. So to solve for y, you can simply divide both sides by 7. Then this one will be y is the same as 2. And you're done. So you have solved for, actually we are yet to solve for x, we have just solved for y. So to solve for x, just pick one of the two equations. So I think the first one is much easier despite the fact that it has a negative here. As you can see, the numbers here are easier. They are all ones. We have 1x, 1y, and a 1 there. So say x minus y is the same as 1. So you can just substitute this in there and say x minus, where you have y, just put a 2, then equate this to 1. Collect the like terms. You have 1, you take the negative 2 to the other side, you have positive 2. So that x is the same as 1 plus 2, which is 3, and you're done. Lastly, we have this problem here. So I'll do the same. I'll eliminate the x since we eliminated the y's in the first couple of examples. So to eliminate the x, I'll get the coefficients of the x variables. So I'll get the 2, which is the coefficient of this, and put it there. And then I'll get the coefficient of this, which is a 1. Of course, it's a negative 1, but I don't want to include the negative sign. If you want to include the negative sign, you can still do that, except that you have the same signs here, and then you will have to multiply one of the two equations by a negative number so that you have different signs. So for me, I'll ignore the negative sign and get 1 as the coefficient of x. So you can say 1 multiplied by 2x, this is 2x. 1 multiplied by minus 6y, this is 2 minus 6y. 1 multiplied by 0 is 0. And then 2 multiplied by negative x, this is negative 2x. 2 multiplied by 9y, this is 18y. Then 2 multiplied by 12, this is 24. And then now we have what we wanted. We have the same coefficients and the signs are different. So all you have to do is apply your knowledge from assignment 1 and add the two equations. So this plus this, because the signs are different and the numbers are the same, this will just be a 0. That's like 2x plus negative 2x, and then negative and positive is negative, so 2x minus 2x is 0, so you don't even have to write the 0 here. And then you have negative 6y plus 18y, so this one will be a 12y. Remember, 6y plus positive 18y. We have different signs here, so you can just subtract and get the sign from the bigger number, which is 18. And then we have 0 plus 24, which is 24. And then to solve for y, you can simply divide both sides by 12. Then this would be y this side, because this into this is 1. And then 12 into 24, this is 2. And then lastly, you can solve for x. Just pick one of these two equations and substitute the y variable. So I'll pick the first equation. We have 2x minus 6y. We don't know what the y variable is. Oh no, we do. Y is 2, but we don't know what the x variable is. So to solve for x, we can just say 2x, you leave it as it is, and then the y is unknown. The y is 2, so where you have y, just put your 2 and then equate this to 0. Then you have 2x. 6 multiplied by 2, this is minus 12. Then you have a 0. And then you can collect the like terms. Of course, this is just a 0, so you can as well just ignore it, so that you have 2x plus 12. If you want, you can still include the 0, but it won't change anything because it's just like nothing. And then to solve for x, just divide both sides by 2. Then this and that will go, and then you remain with an x. Then 2 into 12, this is 6. So that means y is 2 and then x is 6, and you're done. So now this is your work. You can just attempt these 5 problems and submit your findings. So we have part A, part B, part C, part D, and part E, which is this one.